Hello, this is the walkthrough for the chemistry quick test that you've just done. If you're watching this in the following year, beware, this probably won't be the same as the test that you're about to do if you're thinking of finding out what the answers are and then cheating, so just beware. However, it will talk you through how to answer some of the questions and some of the key ideas. Those of you who have just done the test and therefore doing this because it's a set task in my lesson, what I advise you to do is to watch and listen very, very carefully. You make your corrections as we go along. Being a recorded video and it's only you watching it, there are two things you can do. First of all, you can always set the language on the subtitles on YouTube to match your native language, if that helps you. You can also pause, so that if you want to actually write down any explanations or look anything up, you can pause and do so. In fact, you're very much encouraged to do so. So first of all, we're starting off with, obviously in a test, the first thing you do is you write your name like that, and then you're just answering the multiple choice questions. Multiple choice questions, in a real exam you get a little sheet that you've got to sort of colour in various boxes. In these sort of short tests, as long as I can see which answer you've selected and you've only selected the one, then obviously that's good enough for me. So the first question says an atom of any element must contain equal numbers of the following. Now if it's an atom, it means it's not an ion. So if we think about it, an atom is made of neutrons, protons and electrons. The proton number, or the atomic number, tells you which element you have and is positive. The electron is negative. To be an atom, it has to be neutral. So you have to balance the number of positive charges with the number of negative charges. So the answer is that you must have equal numbers of electrons and protons. If not, the atom would be charged, and it wouldn't be an atom, it would be an ion. Next question. Naturally occurring hydrogen exists of two different isotopes. These are hydrogen 1 and hydrogen 2. Which diagram shows the arrangement of particles of the two isotopes? So we know that isotopes means you've got the same number of protons, okay? But a different neutron number, different number of neutrons. So what we're looking at is the idea that hydrogen has got one proton. We can see that the atomic number here means it's got one proton. So first of all, any arrangement here that's got two protons or no protons would be incorrect. So that's not right. That's not right. So all the rest have got one proton in them. Now the next one, if the atomic mass is 1 and the atomic number is 1, then that must be one proton and no neutrons. That one must be one proton. It's got to be, because it's still hydrogen. But this time we've got an atomic mass of 2. So if you've got two particles, one of them is a proton, the other one must be a neutron. Okay. So we're looking for one here with one proton and one neutron. So we've got one proton and no neutrons. So it could be that one. It could be that one. And we're looking for one with one proton and one neutron in the nucleus. Proton, neutron. And there'll be one electron. So it could be that one. Okay. Or it could be that one. So, well, we know that one's not correct because there's no electrons here. So it's not an atom. So the only one it could possibly be is C. On to part 3. Now if you look very carefully at question 3, there are a couple of different ways of doing it. The easiest way of doing this particular question is to look at the pattern of the periodic table. You know that if you make an imaginary line about sort of there-ish, then pretty much everything on this side is metal and everything on this side is non-metal. So it would be B. However, if you look carefully at the periodic table, you can actually identify where B is, because B, well, that's group 8, so that would be group 7, this is group 6, and it's 1, 2, 3 down. So if we look at this, we've got group 6, 1, 2, 3 down, group 6, you've got sulphur. Now, those of you who know what sulphur is, you realise straight away that that is definitely not a metal. So that's definitely a non-metal. So of all those, the only one that's a non-metal is B. Moving on to question number 4. Question number 4 says the diagram shows one of the ways of representing an atom, in this case element X, whatever that is. It wants to know to which group of the periodic table does X belong. So the group is the number of electrons in the outer shell. So we've got 1, 2, 3, 4, 5, 6. It's not an ion, so we don't have to worry about anything else there. We assume it's a neutral atom, so there are 6 electrons in the outer shell, so it is indeed in group 6. Question number 5. There is a link between the electron arrangement of an atom and its position in the periodic table. The table below shows the electronic structures of the 4 elements. Which one is a noble gas? So the noble gas, remember, is group 0. So it has a full outer shell. Well, you should recognise that for shell 1, the maximum you can have is 2, and for shell 2, the maximum you can have is 8. So this one is not a full outer shell. This one is not a full outer shell. This one has a 0, and this one has a 0. So we go into the inner shell. Well, you can have a maximum of 2. So this one has got 1. So that shell is not full. So the only one that's full there is that one. So A is your answer to that question. Question number 6. Metals usually form compounds involving ionic bonding. So this is bonding of ions. So how do metals form their ions? Now metals, remember, they're on the left hand side. They're on the left hand side of the periodic table. So on the left hand side you've got very, very small numbers of electrons in the outer shells, so it's easier to remove the electrons than it is to add them. So the metals become ions by losing electrons. Okay, you can't lose protons because protons are part of the nucleus, they're completely bound to the material. We know we can't gain electrons because that's not an easy way to make a full shell. And again, you can't gain protons because there's nowhere to get the protons from. So question number 7. Chlorine is a highly reactive non-metal. What particles are gained by chlorine when it reacts with potassium? So the non-metals on the periodic table are all on the right hand side, which means that they have almost full shells. So the best way to have a complete outer shell, to fill the outer shell, is to add electrons. Electrons, remember, are negative. So we know that it will gain electrons. What you have here are charged atoms, otherwise known as ions, and it's an ionic structure, and it shows you a picture of it. But more importantly, what you're doing is you're thinking about what the substance could actually be. Well, if we think about it, it can't be iodine. It can't be iodine because iodine is a non-metal. For an ionic substance, you need a metal and a non-metal. Water, well, that's H2O, and they're both non-metals. The diamond, that's just carbon, which is a non-metal. So we're looking at this particular element. Remember what we talked about briefly about ionic substances and naming them. So you have the metal here. If you want to look it up and be sure it's a metal, potassium is here on the left hand side. It is an alkali metal. You know it's a metal because it's on the left hand side of the periodic table, so that's a metal. And the other one is bromide, which means it's a bromine atom. So it's a halogen. It's group 7, and group 7s are non-metals. Bromide just means it's an ion of bromine. Remember, ide is an ion. So this is potassium bromide is a metal and a non-metal. So being a metal and a non-metal, you know that that's going to be an ionic bond. So it's got to be C. On to question number 9. You've got some pictures of covalent bonding, and it says which one is methane. So methane is one of the examples that we've used extensively when we're talking about covalent bonding. So methane, if we think about it, is CH4. Okay. Now, are you expected to remember it? Well, not quite at this stage. By the end of your GCSE, you will be able to remember it, because you'll study alkenes and alkanes and organic chemistry. But how would we know it? Well, we know that hydrogen can form one bond because it's got a single shell. It's got a single shell, and that single shell can contain 2 electrons, of which there is 1. So there's 1 electron missing, 1 electron there, so it can only form one bond. Carbon is a group 6 material. Therefore, therefore there are 2 electrons in the inner shell, and 6 electrons. I do apologise. Carbon is a group 4 material. I do apologise. Carbon is a group 4 material. Therefore, it has 6 electrons on the inner shell and 4 electrons in the outer shell, which leaves you with 4 gaps, because you can have up to 8 electrons in that outer shell. So there are 4 gaps, and therefore it could form up to 4 bonds. Okay, so if you've got 4 bonds there, then we can start to have a look at that. Well, it's going to be carbon's forming 4 bonds, so it's not that one because there's only 2 bonds. That one's not right because that's assuming hydrogen can form 4 bonds. It can't do that. It could be that one or it could be that one, and they look the same until you look really closely. That's a cross and that's a dot, because the cross represents the electrons orbiting the hydrogen nucleus, and the dots represent the electrons orbiting the carbon nucleus, and these electrons are shared. So it's C. Remember, these are called cross and dot diagrams, and that's for a reason, because there are crosses and dots. So that one has got to be wrong. Now this looks like a more difficult question than it is. Magnesium reacts with sulphur to form magnesium sulfide. Magnesium sulfide is an ionic compound. Which statement is not correct? Now, loads of people make mistakes because the human brain isn't really wired to work with negatives. So what we have to do instead is we have to just go back and keep on remembering we're looking for the one that's wrong. So the first one is electrons are shared between sulfur and magnesium. Well, they're not shared, are they? They're transferred. So A looks like it could be the one that's wrong, but we'll just double check. Electrons are transferred from magnesium to sulfur. Well, that's correct, because the magnesium is a metal, so it'll lose electrons. Sulfur is a non-metal, so it gains electrons when it ionizes, and so the electrons are transferred from magnesium to sulfur. The magnesium, so that is correct. The magnesium ions are positively charged. That's correct, because they've lost electrons. And the sulfur atoms gain electrons. That is correct, because they become negative. So the one that's not correct is definitely A. When you're doing this kind of question, that's the process you have to follow. What happens sometimes is people get in a bit of a hurry, and they start reading through the sentence and they just circle the first one they see that's right. So, and that obviously would definitely give you would not give you the mark. So you just got to remember that. Number 11, again, this one looks harder than it is. This is a classic past exam question. It says which row shows the formulae of sodium hydroxide and potassium hydroxide. Remember, hydroxide is OH negative. It's an ionic molecule. So it's OH. So that's why they all end in OH. So what we need to do is look at the names of the metals and look at the symbols. So if we look for potassium and sodium on our periodic table, there's sodium, it's Na. Potassium is K. So the one that's sodium will be an NaOH. So it's that one, and it's not that one. Okay? The S would be for sulfur, which wouldn't make any sense at all. The potassium, remember, is K. So K, not P, because that's something else. That's phosphorus, which is not potassium. So the K is potassium. So we're looking for the row with them that are both right. So they're both right here. So we label that A. Now, as part of your examination, your real examination, you'll do a paper with written answer questions. And there you have to read the questions really carefully. So it says, state in terms of atomic structure which number determines the order the elements are in the periodic table. And they're in order of proton number. Remember that atomic number has a few different names, of which proton number is one. Why is it proton number this time? Because it's in terms of atomic structure. So they want it to be in terms of the number of protons. They don't really want it as atomic number. They want you to say proton number, or the number of protons. Now this one, a lot of people has a lot of people searching for their periodic table, which can help sometimes, but actually it's all about knowing the positions of these elements in the periodic table. So part of the periodic table is shown in figure 2.1. The letters are not the symbols of the elements. So it says choose the letters from A to H to complete the sentences. So the most reactive element of group 1 is, well, group 1, remember, is the alkali metals. They become more reactive as you go down. So that would be F. Okay, that would be the one that's most reactive out of 3. The further down the periodic table you go, the more reactive the alkali metal is. With the halogens in group 7, so this is group 7, the halogens in group 7, it's the opposite. It's more reactive as you go up. So the one that's most reactive is D. So it says the least reactive must be H. The next part is to do with the 3 elements with the same number of outer shell electrons. In other words, they'd be in the same group. Well, the only group here with the only group here with 3 letters in the same column is this one. So in any order, it's B, E, and F. So then you're suggesting 2 properties of the element labelled G. Now, a lot of people get very confused about what we mean by properties. A property is something it does, not something that identifies it particularly. So G is in the middle here. It's a metal. So we're saying suggest 2 properties of metals. So they would conduct electricity. They could conduct heat as well for exactly the same reason. You could suggest that they were shiny. Okay? And actually, I would also accept magnetic, but only in this case. The reason being is if we look up what that one actually is in the periodic table, okay, we would see that it's cobalt, and it just so happens that cobalt happens to be iron, nickel and cobalt happen to be the only magnetic elements on the periodic table as far as I know. So it's by a happy coincidence, yes, you could say it was magnetic because it is actually cobalt. However, if we're just using that as a definition of metals, remember you shouldn't really say magnetic. Aluminium, Al, is group 3. Oxygen is in group 4. Sorry, group 6. I do apologise, I'm getting confused with my Roman numerals there. Deduce the charges on the aluminium ion and the oxygen ion. So what we're doing is we're looking at what happens to these elements. So you've got aluminium, it's in group 3. Aluminium's a metal. Okay, hopefully you already know that aluminium's a metal. Therefore, it would need to lose electrons. Okay, because that's what metals do when they ionize. If it's in group 3, that means it's got 3 electrons in its outer shell. So if it's got 3 electrons in its outer shell, that means it would lose 3 electrons to clear the outer shell and have that outer shell empty. Oxygen is in group 4. Oxygen's a non-metal. Oxygen is not a metal. So if oxygen is not a metal, we know that that will gain electrons. Sorry, group 6. I do apologise again. I've said that again. It will gain electrons. If it's in group 6, and I'm going to write that down because I seem to be making a mistake with that occasionally. If it's in group 6, then it means it could gain up to 2 electrons before it fills the outer shell. So it would gain 2 electrons. So if the aluminium has lost 3 electrons, well, when you lose electrons, electrons are negative, so you lose negative charge, which means you become positive. So the aluminium ion charge is +3. Okay, now with oxygen it's in group 6, which means it will gain 2 electrons. Electrons are negative, so it will gain a negative charge. It will gain 2 of them, so it will be -2. Now this one is quite hard, so you have to use a bit of logic. You've got magnesium ions have the formula Mg+2. Nitride ions have the formula N3-3. So what we've got to think about is what's happened for those to become ionized. Well, the magnesium has to have lost 2 electrons. We know that the nitrogen has to gain 3 electrons. So that magnesium will give it 2 electrons. So you need another magnesium ion to give it its 3rd electron. Now, because you've got magnesium still ready to give up another electron, you need another nitride ion, okay, to take that electron. So you need another magnesium atom to give the 2 electrons to the nitrogen, okay, because the nitrogen has gained 3 electrons. So that's 1, 2, 3. The magnesium has lost 2. 1, 2, 1, 2, 1, 2. So we've got 1, 2, 3 magnesium atoms, 2 nitride ions, okay. So it's Mg3N2. Okay, so that's how we denote those particular atoms. That was quite a tricky one. That's one of the harder things that you'd ever be asked to do in this particular topic. So on to the last part, which is just 2 simple questions. And so this should have been number 14. Which particle has the smallest mass? The particle that's got the smallest mass, well, in the middle of an atom, you know you've got neutrons and protons, and around the outside, you know you've got electrons, and the electrons don't have a lot of mass. So the thing that's got the smallest mass is the electron. Number 14, which statement about compounds is correct? So we're looking for the one that's correct. So an ionic compound contains 2 metallic elements bonded together. Well, that's not true, because if you've got 2 metallic elements, that's a metallic bond, not an ionic bond, okay? So that's not true. An ionic compound, metal ions are negatively charged. Well, that's not true, because we know they're positive. When metals combine with non-metals, electrons are shared between the atoms. Well, are they shared? No. If you've got a metal and a non-metal, then that's an ionic bond. So what happens is that the metal gives some of its electrons to the non-metals, and that's why they both form opposite ions. So it's not shared, they're transferred. So that one's not right either. When 2 non-metals combine, molecules are formed. Well, that's correct, because molecules, remember, are caused by covalent bonding. So when 2 non-metals combine, molecules are formed. So that should give you the guide that you need. You need to make sure that you've done your corrections, but also made the notes that you need to make so that you can be sure that you've understood not just what the answer is, but why that's the answer, because that will help you a lot in the future. If you want to watch the video again, you can do so in your own time. But what's really important now is just making sure that you understand why you got the questions wrong that you got wrong, and what it is you need to do to get to improve for the next test.